Mr. President, you have a very big job in lots of science and technology areas during your administration. I'm going to talk about one of them. Before I do, let me just say that once Richard Feynman said that Einstein was a really big man. He had his feet firmly on the ground, and at the same time he had his head in the clouds. So he was both a practical scientist and a visionary. Your administration must be equally big, both practical and visionary. The hard part is to find the path from visionary to practical, if there is one. Franz Kafka once said in a different context, there is a goal but no way, and that's what has to be sorted out. I'm going to talk about practical and visionary nuclear options, both nuclear power and nuclear weapons. Let me start with what we do about nuclear power. The practical ideas for the next generation are still going to be once-through reactors, as they are called. They burn the fuel once, and that fuel is then turned into waste. We're still going to be talking about these once-through reactors, but instead of being cooled by water, as they are today, which is very unsafe, we are going to look toward high-temperature gas reactors, pebble bed reactors, which are proliferation resistant, a very important consideration. What's the difference here? A water reactor uses a very high power density in the reactor itself, and water is the coolant. We all know from examples such as Chernobyl that if that water is lost, very bad things can happen. For example, some of the water can react at that very high temperature to form hydrogen, which can explode. The water can turn into steam and explode and spread radioactivity all over the countryside. In contrast, a high-temperature gas reactor uses the gas helium as its coolant. This gas is completely non-radioactive, cannot be made radioactive, and its loss is of no consequence whatsoever, since the reactor will not melt down if it loses all that coolant. Now, that's fine for the upcoming few decades of reactors, but the next generation, which is currently visionary because of technological problems, because of political problems, because of proliferation problems, will use so-called closed fuel cycle, in which the fuel is recycled one way or another. Fission-fusion hybrids, which will use the neutrons from a fusion reactor to create fission in a bed of uranium, and that's a much more efficient way of burning uranium and making more fuel. High-energy accelerators can generate energy and transmute a large part of the waste, which is very useful, by using neutrons of higher energy than occur in normal reactors. And then, of course, there is still the visionary promise of pure fusion. Let me turn briefly to what we do about nuclear weapons. What is practical today and what you have supported in your administration is to reduce the stockpile down to perhaps 1,000 weapons, both for us and for the Russians. You must continue to support stockpile maintenance technology, which will assure us of weapons reliability and safety without underground tests. And that is not going to be cheap, but it is going to be essential. And then finally, as you have urged, the Senate must ratify the Comprehensive Test Ban Treaty. That treaty was signed in 1996 by President Clinton and gone unratified to this day. And of course, the vision is to find a path toward nuclear disarmament for all nations. Now, nuclear power is just a source of power that we can't ignore, even with all your interest and the interest of the rest of the world in renewable and ecologically friendly power, such as solar power and so on. The rap against nuclear power generation is that it's unsafe, but it can be made safe. In a high-temperature gas reactor, the power density is low. It's cooled by a non-radioactive gas, helium, and if that coolant is lost, the reactor will cool down without further event. It will not melt. There will not be a China syndrome, as there was in Chernobyl, for example. Another problem with nuclear reactors, of course, is proliferation. And here is the problem. The Non-Proliferation Treaty provides, in Article 4, that all nations have the inalienable right to peaceful nuclear power. That nuclear power, as it comes from reactors of today, requires enrichment of uranium in the rare isotope uranium-235. Once that enrichment process has gone to the level needed for reactors, which is only a few percent, it is really quite easy with the same technology to enrich it to the 90% level at which weapons can be made. So how do we make them proliferation resistant? One way is through a pebble bed reactor, which I spoke of briefly before, in which the fuel is in the form of pebbles about the size of golf balls, which by their construction are more proliferation resistant than some of the fuel assemblies used today. Not proliferation proof, but proliferation resistant. Now, these are still once through reactors. Let me talk just briefly about closed cycle reactors, in which today's waste may be tomorrow's fuel. Now, many people have urged that we reprocess this fuel now, this waste now, but we don't have to do that. There's no need for it now. We can store it, and particularly we should store it in its very highly radioactive form that it emerges from the reactor, so that people who would like to proliferate would find themselves in mortal danger if they touch that waste. And we can wait decades for developments in transmutation and reprocessing, or transportation without reprocessing, whatever seems to be the best technologies in the future in another 50 years. The importance of this is that when and if the visions of a closed fuel cycle come to pass, uranium supplies last for thousands of years, not tens of decades. That is to say, it could be that if the plans of the various nations that wish to have peaceful nuclear power are brought fully to fruition, that we would run out of proven uranium ore reserves within this century. Let me talk very briefly now about nuclear weapons. Of course, we don't want to use them, but that doesn't mean we can ignore them, quite the opposite. So I'm going to talk about some policy goals first, and ask the question, do these goals need much technological support? And my answer is absolutely. Nuclear weapons are much too dangerous to ignore. So the policy goals, which your administration endorses, is to ratify the Comprehensive Test Ban Treaty. Let me speak for a minute about that. Years ago, technological studies were made of the effect of the CTBT on America's nuclear weapons, and the scientists who studied these things found that we, the United States, had very little to lose by ratifying the CTBT and much to gain, because our knowledge of nuclear weapons is sufficiently advanced that we did not need nuclear tests. On the other hand, would-be proliferants would be very hard-pressed to make sure their weapons could work right if they didn't do nuclear tests. Furthermore, there is now in place an international monitoring system which is capable of detecting even small nuclear weapons practically anywhere on Earth, so that it's very hard to cheat on the CTBT. The second goal, within decades, 1 decade or 2, set and carry out the goals for stockpile reductions to perhaps 1,000 weapons on the US side, 1,000 weapons on the Russian side. Anything more than that is beyond rational use, and doesn't make any economic sense either. Other goals which need no technological support really are institute a no first use policy, and remove weapons from launch on alert. Unfortunately, that is the situation both in Russia and the United States these days. And then in the very long term, nuclear disarmament. Now, nuclear disarmament is not easy. The reason is that the Non-Proliferation Treaty provides that all nations have the right to peaceful nuclear power. As I said earlier, that means they can, if they wish, enrich uranium to weapons levels. And how are we going to control, on the one hand, the civil nuclear power and prevent, on the other hand, nuclear weapons? This is very difficult. So these policy goals are going to need a lot of technological support, especially nuclear disarmament, because the technology for detecting and sensing violations of the Non-Proliferation Treaty are going to be not only complicated and expensive, but intrusive. So we're going to need, at the moment, in the practical level, technological vigilance must be continued to improve the safety and avoid aging failures of our stockpile. And then in the visionary future, worldwide disarmament technological challenges are extreme, and you must handle them. Thank you very much.